Good morning, everyone. This is Srikanth, Assistant Professor of Triple E Department. Today, I'm going to deal with the construction of DC generators and operating principle. So, let us go with the basic construction details of DC machine. So, before going to that, what are the contents we are going to discuss and what are the functions of DC machines? Let us discuss. So these are the contents we are going to have in the DC machines. The first is the principle of operation and construction and types of DC machine, power flow diagram and speed control. The DC machines are DC machines are generally divided into DC generators and DC motors, where these DC machines are going to work on the DC supply. That is, either if it is generator, it gives the DC supply, it generates the DC voltage. Whereas if it is a DC motor, it will take the DC voltage and it will work. And these are very similar to the AC machines, but only the change is it is going to have the outputs and inputs as the DC. And here we are going to have a special mechanism in order to convert the AC, whatever the generated AC voltage into DC by using the commutator. That is the reason why these DC machines are also called as commutating machines. And DC generators are not as common as they use because direct current is required and mainly produced by using the electronic rectifiers. We need to have the electronic rectifiers wherever we want to use the DC motors or DC generators. So, while DC motors are widely used, such automobile, aircraft, and portable electronics in speed control applications, because the operation of DC machine, how we are going to control the speed of the machine is very simple. So that's why in some special applications we are going to use the DC motors, whereas under normal operating conditions we can use the AC motors. Now, what is a generator? A generator is nothing but the name itself says that generator. It generates power, it generates voltage. That is, it generates the electrical energy. It generates the electrical energy. How it generates? Because we know that energy cannot be created nor be destroyed. Energy will transform from one form of the energy to another form of energy. So, one form of energy is required to convert into other form of energy. Which form of energy is converted into electrical energy? That is, here we are going to convert the mechanical energy into electrical energy. That is, rotational energy is converted into electrical energy by using Faraday's law of electromagnetic induction. By using Faraday's law of electromagnetic induction. So, in the Faraday's laws of electromagnetic induction, whenever a current carrying conductor placed inside a magnetic field, placed inside a magnetic field, an EMF will be induced. An EMF will be induced. So here the EMF is inducing, and that EMF is proportional to rate of change of flux linkages. Rate of change of flux linkages. So here we require a conductor and a magnetic field. A conductor and a magnetic field. So here, if we take a single conductor, if we take a single conductor, the EMF induced will be less. So in order to get the maximum voltage, what is based on our requirement, to get the voltage of, generally we are going to have the DC generators of 220 volts. In order to get the 220 volts, we should form a coil. We should form a coil by using the conductors. Just number of conductors placed together will form a coil. That coil will generate the voltage. So here one thing which is required in the generators is the magnetic field, and the second thing which is required is the conductors. So the two coils, which is, in order to get the magnetic field, either we have to use the permanent magnets, or electromagnets. So in order to use the electromagnets, that is, electromagnet is a magnet which is going to produce the flux once the supply is given. That is nothing but, to a coil, when we give supply, according to right hand thumb rule, whenever a current carrying conductor, current flows in the direction of thumb, the flux will be developed around the conductors in the remaining fingers direction. So the flux will be produced. Once the flux is produced in the conductors, that will act like a electromagnet. So electromagnet is formed and conductors are there. So we can get the voltage by using the Faraday's law. This is the basic working principle of generator. And if we go with the motor, how will be the working principle? Here in the motor, we are going to give the electrical energy which will generate the mechanical energy, which will convert whatever the electrical energy is converted into mechanical energy. So here, how electrical energy is converted into mechanical energy. Here already we have discussed, there are two conductors, there are two coils in the DC machine. One coil is used to produce the magnetic flux, and the second coil is to generate the voltage in the case of generator. If it is a motor, the same coil will be used for generating the main flux. That is, we are going to give the supply to the coil. That coil is called armature winding. To the armature winding, we are going to give the supply. When we have given supply to the conductor, the flux will be developed. Once the flux is developed, and here we are going to make an arrangement such that our actual electromagnetic flux, main flux, and this armature flux, these two should be perpendicular to each other. Then when the two fluxes are perpendicular to each other, there will be a force of attraction or a repulsion. So here, this force of attraction or repulsion will make, here we are going to have the main field winding on the stationary part and armature winding on the rotary part. That is nothing but, that is a rotating part. So there will be a force develops inside the magnetic fields, and that force will be on the rotary part. So the rotor starts rotating. So this is the way we are going to get the torque in the DC machine. Let us go through the constructional view. Here in DC machines, for both generators and motors, the construction is same. Only the difference is how it is going to operate. How it is going to operate. That is only the difference. So here, this is the basic constructional view of DC machine. In the DC machine, majorly we are going to have one is one is stator, and another one is the rotor. On the stator, we are going to have main winding or field winding, we can also call. And on the rotor, we are going to have the armature winding. We are going to have the armature winding. And the outer portion, whatever the outer portion is the stator, and this is the inner portion which is called rotor. On the rotor, we are going to have the armature and armature conductors. This is the rotor which is having, and here on this rotor, these are the armature conductors. Whatever the circle manner which is having plus symbol and dot symbol, these are the armature conductors. And for the armature conductors, in order to collect the current, we are going to have the brushes. This is only simple view. I will show you the complete cross-sectional view clearly, so that you will have some more parts in the rotor. And the next part is on the stator is yoke and field poles and field winding. Field poles and field winding. Field poles are going to produce the magnetic flux, and these field poles are going to provide the flux in the inside the machine. This is the way we are going to give the mechanical input. Here we can see clearly, this is the mechanical input, either by means of turbine or some other equipment we are going to use to give the mechanical energy. Once if we give the mechanical input, immediately the rotor starts rotating. When the rotor rotating inside the magnetic field, so according to Faraday's law of electromagnetic induction, an EMF will be induced. Here we are going to get the mechanical input, because here we are going to give the DC supply. These are the basic pictorial representation. We'll go in detail with the different constructional details. Here, first we will go with the constructional details. Then after, we'll go with the how the voltage is going to be generated in the DC generator. So here, a DC machine which is going to have, we have already discussed, which is going to have the two windings. One is armature winding, one is field winding. And where we have to place the armature winding and field winding. So armature winding is placed on the rotor and field winding is placed on the stator. These are the major two parts, so which are going to have the windings on the stator and windings on the rotor. So the outside part of the machine is called the yoke, and on the yoke we are going to have pole core and pole shoes, and on the magnetic frame we are going to have the field winding that is placed on the stator. And the next one is we are going to have where we have to place the armature. on the armature core, and the next armature winding on the rotor in order to get a DC supply. Just we are going to generate the AC supply. So in order to convert the AC supply into DC, we need a commutator. And then to collect the current from the conductors, we need brushes and end housing, bearings and shaft. These are the external in order to get the clear operation of the DC generators we require. These are the main constructional details of the DC machine. Now let us go with one by one. This is the yoke, where the yoke is nothing but outer part. Yoke is nothing but outer part of the machine, where all the parts of the DC machine are inside the yoke, and this is connected. This is going to be placed to the foundation because this has to provide the mechanical protection. This has to provide the mechanical protection to the inner parts of the machine. So the main thing of having yoke is which is going to provide the mechanical strength to the machine, and it also provide low reluctance path for the magnetic flux. These are the two purposes of yoke, and these are made with the yoke is made with cast iron for smaller machines and cast steel or fabricated rolled steel for larger machine. Based on the size of the machine, we are going to use the different material. One is cast iron, and for a larger machine, cast steel or fabricated rolled steel we are going to use. And on the uh, yoke, in order to place the windings, we need the pole core. We need some magnetic material where we are going to place the windings in order to generate the main flux. So for that we need the pole core, and these pole cores which are going to have uh, the pole shoes, where the pole shoes are going to provide the uniform flux distribution inside the inside the machine. We are having a rotary type. So if we have a box type pole shoes or poles, then what happens? The flux will be distributed in a non-uniformly. So in order to get uniform flux distribution, we need the shape of the pole shoe should be in the form of circular manner. That's why we are placing the pole shoe in this way. So these are going to serve the following purpose. They support the field or exciting coils. Here we are going to place the field coils, and they distribute the magnetic flux on the armature periphery more uniformly. That is, on the armature, the flux will be magnetic flux will be distributed more uniformly. And these pole shoes are going to have the larger cross section, so the reluctance of the magnetic path is reduced. That is, reluctance of magnetic path is nothing but reluctance is nothing but in the magnetic circuits. It is just like a resistance in the electrical circuits. So here the reluctance of the magnetic path is reduced. The pole core and pole shoes are made of laminated steel assembled by riveting together under hydraulic pressure. These are laminated steel we are going to use by riveting together. That means so many sheets are going to be placed together, and they are going to be bolted under hydraulic pressure. And the next one is field or exciting coils, where field coils or exciting coils are used to magnetize the pole core, which are going to magnetize the pole core. Once if we place the winding and if we give the supply to the windings, the flux will be generated, and that flux will flow through the magnetizing pole core. And here we are going to use the enameled here we are going to use the enameled copper wire for the construction of these coils. When direct current is passed through these coils or winding, it sets up the magnetic field which magnetize the pole core to the required flux. And the next one is the armature core, which is armature core is a rotating part of the DC machine, where this armature is placed on the rotary part. So this armature core is used to place the conductors is to place the conductors, and this armature core is going to have some slots where we can place the armature conductors, that is in order to produce the magnetic flux. Here these are like this, we are going to have the slots. On these slots we are going to place the windings. On these slots we are going to place the windings, and this armature core is going to have a circular manner so that it can easily rotate, and this armature core is laminated in order to reduce the eddy current loss. And the next one is the armature conductors, where this armature conductors or armature winding, when the number of conductors in the form of a coil placed inside the slots of armature core, then that will form a armature winding. That will form a armature winding. And here, this is the place where the conversion of power takes place. If it is in case of generator, mechanical power is converted into electrical power, and in case of motor, electrical power is converted into mechanical power. Because when we are having two fluxes together, then only two conductors and one magnetic field, then only we can convert either mechanical energy into electrical energy or electrical energy into mechanical energy. And these armature windings are of two types. One is based on the connection, how it is connected. The first one is the lap winding, and here the conductors per coil are connected in such a way that number of parallel paths are equals to number of poles. In lap winding, the number of conductors per coil are connected in such a way that which will provide the number of parallel paths that are equals to number of poles. If each machine has p number of poles and z number of conductors, p number of poles and z number of conductors, then there will be p number of parallel paths. Then there will be p number of parallel paths, and each path will have z by p number of conductors in series. Each path is going to have z by p number of conductors divided by number of parallel paths. Number of conductors divided by number of parallel paths in series. Also, the number of brushes also are equal to the number of parallel paths. So, whenever we are having number of parallel paths, we have to collect from the parallel paths. What are the current we need to collect from the parallel paths. So, out of which half of the brushes will be positive and the remaining will be negative. Definitely, we are going to have the positive and negative for the voltage. So, if there are n number of brushes are there, n by 2 brushes will be positive and n by 2 brushes will be negative. And if we take the wave winding, here the conductors are connected such that which is going to provide only two number of parallel paths. Only two number of parallel paths, which is going to have two number of brushes. And the next part is, and most important part, is the commutator. And this is the part which connects the armature winding and the brushes. Here it serves the following two purposes. It connects the rotating armature conductors to the stationary external circuit through the brushes. It converts alternating current induced in the armature conductors into unidirectional current in the external load circuit in generating action, and it converts alternating torque into unidirectional in case of a motor. So this is the major function, major component where the AC and DC machines difference. So this commutator is going to made with mica insulation, which is going to convert the AC supply into DC and whatever the alternating torque into unidirectional torque. And the next one is brushes, and of brushes are made of high grade carbon. They form the connecting link between the armature winding and the external circuit. The brushes are held in particular position around the commutator by brush holders. End housings. Here the end housings are nothing but how we are going to close the other two parts of two sides of the machine. That is, these are attached to the ends of mainframe and support bearing, where we are going to, which is going to support the bearings. The front housing support the bearing and the brush assembly, whereas a rear housing supports the bearing only. Okay, only which is going to support both brush assembly, whereas rear housing supports only bearings. The bearing and brush assembly, whereas rear housing, which is going to supports only the bearings. And the function of bearing is to reduce the friction between rotating and stationary parts. These are fitted in the end housings, generally made with high carbon steel, and this is done in the construction of machines, and which is going to based on the type of rotor which we are taking. Based on that, the size of the bearings is going to depends. And the next one is shaft. Here, this is the shaft which is going to transfer mechanical power from the machine and to the machine. If it is a generator, to the machine. If it is a motor, from the machine. And it is made with mild steel with maximum braking strength, and all the rotating parts like armature core, commutator, cooling fan, etc. are key to the shaft. This is the shaft where we are going to have on the shaft only we are going to have all the rotating parts. That is, complete rotor is placed on the shaft itself. This is about the constructional features of DC machine. So in this session we have discussed what is the basic principle of operation of DC motors and generators, and we have discussed the constructional features of DC machine. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.